A complex number is defined as a plus bi or a minus bi. The a is called the real part and the bi is called the imaginary part. This is important to know because when adding or subtracting complex numbers, we add or subtract the real parts and add or subtract the imaginary parts. Let's look at some examples. In part A, we have the complex number 2 plus 3i being added to the complex number 6 plus 4i. We begin by grouping the real parts together and the imaginary parts together. Next we add. This will give us 8 plus 7i. In part B, we have the complex number 4 plus 2i being added to the complex number 3 minus I. Again, we group the terms accordingly. Next we add. This will give us 7 plus 1i. In part C, we have the complex number 6 plus 5i minus the complex number 3 plus 2i. Before we group the terms here, we need to distribute the minus sign in front of the second complex number. This will change the second complex number to minus 3 minus 2i. Now we group the terms accordingly. Next we subtract. This will give us 3 plus 3i. In part D, we have the complex number 7 minus 3i minus the complex number 8 minus 6i. Again, we need to distribute the minus sign in front of the second complex number. This will change the second complex number to minus 8 plus 6i. Now we group the terms accordingly. Next we subtract. This will give us negative 1 plus 3i. When multiplying complex numbers, it is important to know the definition of the imaginary unit I. This unit is defined as the square root of negative 1, which is not a real number, hence the name imaginary. You also need to know that I squared is defined as negative 1. This will be important when you are asked to multiply and divide complex numbers. Let's look at some examples. In part A, we are given 4i times the binomial 2 plus 3i. We use the distributive property to multiply 4i times 2 and 4i times 3i. This will give us 8i plus 12i squared. Since we know that I squared is equal to negative 1, we can replace the I squared with negative 1. Doing so will give us the final answer, negative 12 plus 8i. Note that in your answer, the real part is written first, followed by the imaginary part. In part B, we are given the binomial 3 plus 5i times the binomial 4 minus 2i. We use the distributive property to multiply the two binomials. This will give us 12 minus 6i plus 20i minus 10i squared. Again, we replace the I squared with negative 1 and multiply it to negative 10, making it positive 10. Next, we combine the real parts together and the imaginary parts together. Doing so will give us the final answer, 22 plus 14i. When dividing complex numbers, we need to eliminate the I in the denominator. We use conjugates in a process similar to rationalizing a denominator to do this. Let's look at some examples. In part A, we have the binomial 8 plus 9i divided by the binomial 5 plus 2i. We multiply both the numerator and denominator by the conjugate 5 minus 2i. We use the distributive property to multiply both the numerator and denominator. Next, we see that we have I squared in two locations, so we replace them with negative 1s and multiply them to the coefficients in front. We can also cancel out the negative 10i and plus 10i in the denominator. Next, we combine the real parts and the imaginary parts. This will give us 58 plus 29i over 29. Notice we can divide 29 into both terms in the numerator. Doing so will give us 2 plus I. In part B, we have the binomial 1 plus I divided by I. We multiply both the numerator and denominator by the conjugate minus I. Again, we use the distributive property to multiply. Next, we see that we have I squared in two locations, so we replace them with negative 1s and simplify the double negative signs. This will give us negative 1 plus I over 1. Notice we can divide 1 into both terms in the numerator. Doing so will give us 1 minus I. In addition to I and I squared, we can find greater powers of I by rewriting them in terms of these two. For example, I to the third power can be rewritten as I times I squared. We replace I squared by -1 and then multiply it to I. This means I to the third power is equal to minus I. I to the fourth power can be rewritten as I squared times I squared. We replace the I squareds by -1s and then multiply. This means I to the fourth power is equal to 1. If we continue to evaluate I raised to powers greater than 4, you will see that the answers repeat. Basically, the answers will rotate through 4 values: I, minus I, 1, and -1. Let's look at some examples. In part A, we have I raised to the 12th power. We can rewrite this problem as I to the 4th power raised to the 3rd power. Since we know I to the 4th power is equal to 1, we substitute this value. This gives us 1 raised to the 3rd power, which equals 1. In part B, we have I raised to the 39th power. We can rewrite this problem as I to the 36th power times I cubed. We further rewrite I as I to the 4th power raised to the 9th power. Since we know I to the 4th power is equal to 1, we can substitute this value. We can also replace I cubed with minus I. Next, we evaluate 1 to the 9th power and multiply by minus I. This will give us minus I as the final answer. You should look over the examples on the web page and then test your knowledge using Test Yourself.